Good afternoon, students. Welcome to one more amazing session from Infinity Lane. How are you all, my dear students? This is Suresh, our Faculty of Chemistry from Infinity Lane by Sri Chaitanya. Hope you are doing good. Please confirm, am I audible and visible here? Hi, Annamani. Good afternoon. Welcome to the session. Yes, today we are discussing about chemical bonding, molecular orbital theory. In this NEET STEP UP 2025 program, we are providing physics, chemistry and biology session right from 12 o'clock to evening 6 o'clock. All sessions are absolutely free on this YouTube platform, my dear students. So please get advantage of these sessions. And you please like and share and subscribe to NEET STEP UP, this YouTube channel, and also you can subscribe to the link given down in the chat box and the description box, and also you can join in the Telegram channel so that you will be getting all updates regarding NEET 2025 examinations. And today's session is about chemical bonding, molecular orbital theory. In this session, it is quite important for those preparing for NEET examination for next academic year, and it could be useful for those pursuing 11th standard and completed 11th standard. You are in 12th standard, and also those who are in 12th standard dropped and preparing for NEET examination for the 2025 program. Hope so. We are doing all these sessions absolutely free, and we are providing these sessions right from here weekly. First 3 days about 11th topics and weekly next 3 days about 12th topics. एंड सारा का सारा आपका जो टॉपिक्स है नीट का रिलेटेड है. सो ये नीट रिलेटेड प्रोग्राम में फिलहाल अभी तक हम देख लिया ये केमिकल बॉन्डिंग में कोशल लुईस अप्रोच एंड ऑक्टेट रूल, hypovalent and hypervalent. Also we have seen ionic bond, covalent bond, properties of ionic compounds, and Fazan's rule, and valence shell electron pair repulsion theory, and also we discussed about hybridization with valence bond theory. So if you remember, we have given a very good shortcut trick to identify what is the formula to identify simple hybridization for simple inorganic molecule. Yes, so what late we can start in today's class, molecular orbital theory. And this molecular orbital theory, my dear students, is very important for NEET examination or any kind of competitive examination. So you will be expected at least one question from this molecular orbital theory, my dear students, and it is looks so critical and so complicated when we explain these topics, but I have an amazing trick to discuss a question on molecular orbital theory. So if you use this trick now, so you can get the answer in a simple way, just like a jam and butter, right? So we'll start. So can you able to hear me? Just give me a confirmation in the chat box. You're all with me and you can hear me, you can see me. Hi, hello. से एक थम्स अप देना, एक फायर इमोजी देना, फटाफट देके हम शुरू करेंगे मॉलिक्यूलर ऑर्बिटल थ्योरी. फाइन बेटा. सो Anamani, hi. So where is Nihal here? I just want to see them in the chart. And what about Abhinav? And many regular attendees are there in this class. Okay, so let's talk about molecular orbital theory. So bond order you have to discuss before this. So, hi. So, bond order is the number of bonds between two atoms. Yes, the number of bonds formed between two atoms in a molecule is known as bond order. For example, bond order of hydrogen is 1. Why? Because hydrogen to hydrogen only one bond is seen. Whereas oxygen is 2, oxygen to oxygen, 2 bonds are there. Bond order for nitrogen is 3 because nitrogen to nitrogen, a double bond is seen. Fine, thank you. And here it is, but if you can see the bond order, this valence bond theory, Lewis theory can explain all these things. But oxygen molecule is paramagnetic according to molecular orbital theory, according to experimental, while it is diamagnetic according to valence bond theory, but it is experimentally paramagnetic. Why it is paramagnetic is not explained by valence bond theory, but it is explained by molecular orbital theory. So molecular orbital theory is mostly focuses on electron wave functions and Schrodinger wave equation and total quantum mechanical model of the atom. So what is molecular orbital theory is related? Let us see the bond order. Ozone, the bond, single bond is specified bond, but the total number of bonds are 3 and number of canonical structure 2 and the bond order is 1.5. While benzene, you can see carbon to carbon single bond and the total number of bonds are 3 and the number of canonical structures. So total bond order can be calculated according to Lewis theory. Total number of bonds upon number of canonical structures. So here the canonical structures, the canonical structures are nothing but resonating structures. When you talk about any molecule, according to that, you can take 3 by 2 or 3 by 2, 4 by 3, 4 by 3, 5 by 4 kind of things you can get it. Now, if you see the total molecular orbital theory, here we talk about the bond order is completely different. So it is another approach of chemical bonding known as a molecular orbital theory. It was a latest one in 1932. Mulliken discovered and designed this theory and Hund explained how these molecular orbitals are formed. It is very simple and it is so explanatory in this explanatory part. आपको बता चाहता हूं. So the molecular orbital theory consists of entire molecule as a unit. When it comes to valence bond theory, it is seen that only valence electrons are participating in bonding, while in the molecular orbital theory, the orbitals present in the atom and the orbital present in another atom, so they combine together, this atom and this atom combine and gives rise molecule. So atom A and atom B combine to gives rise a molecule. So in that you have atomic orbitals and it gives rise to molecular orbitals. So these molecular orbitals, how these atomic orbitals electronic configuration is existed, 1s2, 2s2, 2p6 like that. Here also you can see 1s2, 2s2, 2p6. When the atomic orbitals combines together and they lose their identity and they form the molecular orbital, that's a different identity, and this identity is given as molecular orbitals. They given the configuration. So atomic orbitals are monocentric, and to say these electrons are connected to this nucleus, these electrons are connected to this nucleus only. So this is monocentric, while here it is polycentric. So the molecular orbitals that are there are related to this nucleus as well as this nucleus. We can say it is a polycentric. So under these circumstances, this approach recognizes that each of the electron belong to the molecule as a whole. A पूरा molecule का property होगा, है बेटा? And in that, let us see, when the atom to be bonded come close together, and the orbitals of the bonded atoms lose their individual character and merge, they fuse and they overlap to form a larger orbital called molecular orbital. ये खास बात है. And a point के हिसाब से अब ये atomic orbitals combining ना, ये जो atomic orbitals is orbital is a wave according to Schrodinger. So ये wave कैसा बनता है, ये wave कैसा mingle कर सकता है. So that we need to discuss in linear combination of atomic orbitals. LCAO बोलना है बेटा. And like atomic orbitals in an atom, there are molecular orbitals in the molecule. That is what I said. and the only difference is that atomic orbitals electron move under the influence of only one nucleus. That is what you call it as monocentric. Centric means nucleus, right? While the molecular orbitals electron move under the influence of many nuclei, they are called as polycentric. I think you can अंडरस्टैंड ये ब्यूटीफुल नोट्स आपका बना हुआ सो ये नोट्स आपका पीडीएफ फॉर्म में डाउनलोड कर सकते हैं ये टेलीग्राम चैनल पे ये क्लास के अंत में आपको मिलेगा यस दैट्स गुड एंड हियर इट इज द मॉलिक्यूलर ऑर्बिटल्स में देयरफॉर बी डिफाइंड एज द रीजन ऑफ स्पेस associated with all the nuclei of the molecule where the probability of finding of electron is maximum at least with 95% of vicinity. That is what you call it as molecular orbitals. Yes, so molecular orbital is confined to both the bonded nuclei, whereas the atomic orbitals are confined to only unbonded atom. है ना? Right, that's great. You can see here like atomic orbitals which is around the nucleus of an atom, there are molecular orbital which around the nuclei of a molecule. So जो orbital है atom में bonding का पहले atomic orbital है okay? Bonding का बाद ये जो orbital है इलेक्ट्रॉन है ना ये इलेक्ट्रॉन भी ऑर्बिटल में रहना है बॉन्डिंग के बाद दैट इज व्हाट यू कॉल इट एज मॉलिक्यूलर ऑर्बिटल So we'll see the structure of molecular orbital. आपको जैसे s orbital spherical है, p orbital dumbbell है, d orbital double dumbbell है ना? molecular orbital को भी जैसे structure होगा, ये structure कैसा बनता है? ये molecular orbital में main course है. That is given by LCAO. We'll discuss about that and you can see the shape of the molecular orbitals depend upon the shape of atomic orbital from which they are formed. Right? Very good. Nice to see that good response. Okay. The molecular orbitals arranged in the increasing order like atomic orbital. Atomic orbital है ना ऐसे arrange किया Moyles diagram का हिसाब से. So 1s, 2s, 2p, 3s, 3p, 4s, 3D है ना it goes on like that very good and while these molecular orbitals also arranged in increasing order of the energy and these molecular orbitals also filled according to the rules governed by the electronic configuration. So when the atomic orbitals are combined it forms a molecular orbitals. आपका ये combination में जितना एटॉमिक ऑर्बिटल्स कंबाइन कर रहा है ये उतना मॉलिक्यूलर ऑर्बिटल्स फॉर्म होना चाहिए सो द नंबर ऑफ एटॉमिक ऑर्बिटल्स दैट आर पार्टिसिपेटेड शुड बी इक्वल टू द नंबर ऑफ मॉलिक्यूलर ऑर्बिटल्स दैट आर फॉर्म्ड राइट सो दैट इज द मेन इंपॉर्टेंट कोर्स एंड व्हाट आर द इंपॉर्टेंट थिंग्स like atomic orbitals the filling of electrons in molecular orbitals are governed by the three principles. What are these three principles beta aap bol sakte hain yes it is Aufbau rule, Hund's rule and Pauli's exclusion principle. So these three rules has to be followed. What is Aufbau rule? So Aufbau rule says first lower energy orbitals are filled then higher energy orbitals are filled है ना and what is Hund's rule? Yes Hund's rule बोल रहे कि आपका pairing cannot takes place unless the degenerate orbitals are half filled and Pauli's exclusion principle आपका बोल रहे हैं so maximum 2 electrons with opposite spin can be possible in an orbital. So no 2 electrons in an atom can have same set of 4 quantum numbers. That is what you call it as Pauli's exclusion principle. So the combining of atomic orbitals should be comparable energy. So जो orbitals combine atomic orbital combine कर रहे हैं ना ये जोड़ी करने का atomic orbital का energy कम से कम थोड़ी बहुत बराबर होना चाहिए. So वन एटम इतना एनर्जी ऑर्बिटल और दूसरा एटम इतने एनर्जी ऑर्बिटल दोनों मुलाकात करके कंबाइन करना है मुश्किल बात है ना. दैट्स अ वेरी इंपॉर्टेंट पॉइंट. एंड जो थ्योरी पॉइंट्स हम दे रहे हैं ना हमारा तरफ से, ये स्टेटमेंट का वजह से नीट एग्जामिनेशन आने का संभावना है. ओके, सो द कंबाइनिंग ऑर्बिटल्स मस्ट ओवरलैप इन लार्ज एक्सटेंट to gives a good bond. So more the extent of overlapping, stronger is the bond, है ना. That is very important. So the stability of the bond ये extent of overlapping के वजह से stabilize होना है. And the combining atomic orbital should be the comparable energy. And yes, so let's discuss the difference between atomic orbitals and molecular orbitals. Atomic orbitals we can say AO, that is you can say AO. Molecular orbitals that you can say MO. So atomic orbitals they belong, yes, they belong to specific atom only. ये एटॉमिक जो ऑर्बिटल जिन एटम का बिलोंग करते हैं ना, ये एटम का प्रॉपर्टी है. एंड मॉलिक्यूलर ऑर्बिटल बिलोंग टू द एटम्स ऑफ द मॉलिक्यूल, राइट. वेरी गुड. नाउ दे आर इंटरनल कैरेक्टरिस्टिक ऑफ एन एटम. आपका जो ऑर्बिटल्स पता है दैट इज एटॉमिक ऑर्बिटल्स. वेरी गुड. एंड मॉलिक्यूलर ऑर्बिटल्स दे रिजल्ट व्हेन द एटॉमिक ऑर्बिटल्स विद सिमिलर एनर्जी कंबाइन. And they are simple shapes like geometries, you say spherical, dumbbell, double dumbbell and quadri-dumbbell. But they have molecular orbitals have complex shapes. Their shapes are dependent on the atomic orbital shapes. And the atomic orbitals are named as SPDF. The molecular orbitals are named as sigma orbitals, pi orbitals and delta orbitals, but we have only sigma and pi orbitals. So sigma, sigma star, pi, pi star. So this star indicates antibonding and without star indicates the bonding molecular orbitals, my dear students, right. So आगे बढ़ेंगे. The stabilities of the orbitals are less bonding than more than the antibonding orbitals, but the stabilities of these orbitals either more or less than the atomic orbitals, that I am going to show you in LCAO, right. Now, so linear combination of atomic orbitals. So what is this? Actually it is a simple and it is looks complicated, but I want to give it in a simple format, है ना. Yes, it is. So atomic orbital with similar energy they combine. This is an atomic orbital, this is an atomic orbital, they combine and they gives rise molecular orbitals. So जितना atomic orbitals combine कर रहा है वो उतना molecular orbitals आ रहा है. So atomic orbitals with similar energy combine ना, so lower energy orbital एक molecular orbital form होगा and higher energy orbital और एक molecular orbital combine होगा. So that it is, I want to say here, it is atomic orbital and atomic orbital, and this is the scale of the energy. So when they combine, now let us see here. So this is the orbital, atomic orbital, and this is the atomic orbital with similar energy they combine, and they form two set of orbitals, one with low energy orbital, another one with high energy orbital. So low energy orbital, high energy orbital, है ना. So this is what actually atomic orbital of atom A, I just want to say, and this is atom B. So this is atomic orbital according to Schrodinger, and this is actually a wave, plus and minus. This is actually a wave. When these two waves combines now, one is going to form a bigger wave. So this is what you call it as a bigger wave, and another one is going to form a smaller wave like this, So why so? This is formed, my dear students, let us say this is psi A and this is psi b. What is the psi? Amplitude wave function of the electron. So Schrodinger wave equation जिसमें आप psi इस्तेमाल किए ना, अगर ये वेव ऐड करके psi a प्लस psi b होगा, ये psi a माइनस psi b होगा. So this is called additive wave. This is what you call it as subtractive wave. Are you getting or not? This is what is called as lower molecular orbital, where it is bonding takes place. This is what you call it as bonding molecular orbital, and this is what you call it as anti-bonding molecular orbital. So atomic orbital combine and gives bonding molecular orbital with low energy and anti-bonding molecular orbital with high energy. Okay, here I just want to give a small correction over here, my dear students. Here small correction I just want to give you. Look at here. Here this forms addition, this forms subtraction, you can see here. So this forms addition. So when more electron cloud is there, this is called subtraction. Yes. So this is what is psi a plus psi b, and this is psi a minus psi b. So addition gives us bonding molecular orbital. Yes, student of NEET, hi, that's good, nice to see you, congratulations. And this is subtraction gives less an electron cloud between two atoms. This is what you can say it is a subtraction gives rise anti-bonding molecular orbital. You want to give me a question? Yes, पहले concept करने दो बेटा, है ना? अभी मैं खुद क्वेश्चंस देंगे आपका, आप आंसर देना चाहिए. तैयार है? कर सकते हैं? जो भी क्वेश्चन है आप दे सकते हैं और हम भी दे सकते हैं, है ना? Get ready for that. So this is the main course of linear combination of atomic orbitals. That's good, my dear student. That's the spirit. Okay, नाम क्या बेटा? You are a ranker. Congratulations. This is a place where we are talking about the rankers only. So like you rankers should be produced in this platform every year. Shivans. Okay, right, let's go ahead how this actual image happens when the wave comes now. So the wave can be given as constructive interface and destructive interface. So when the wave is being added, so this is psi A and this is your psi B, one wave and another wave. So that this is a wave and this is a wave and this is an atom nucleus, this is an atom nucleus. When these two waves are mixed now, it gives addition of the waves, that is what you call it as psi A plus psi B, right beta, and gives more electron cloud between the nucleus. So that is gives rise molecular bonding orbital. So bonding molecular orbital you can say. When this is destructed, if the wave is destroyed, okay, so it gives like this. So you can say psi A minus psi B, so that between the nucleus very less amount of the electron is produced, है ना? Yes, Rehan Jaffrey, that is subtraction, and it gives rise anti-bonding molecular orbital, and this is bonding molecular orbital. So this bonding molecular orbital is more stable and less energetic, and this anti-bonding molecular orbital is less stable and it is more energetic, that we are discussed. On the energy scale, my dear student, on the energy scale you can see anti-bonding molecular orbital का energy ज़्यादा है. Yes, रेहन जरफानी डीजेनरेट p ऑर्बिटल जब इस्तेमाल कर रहे हैं ना, वहां पर आ जाएगा. डीजेनरेट का मतलब एनर्जी शुड बी सेम, है ना रेहन? Fine, nice interaction. Shivans, hope you are understanding. Rehan? Yes. Now let's talk about LCAO. If the 1s orbital, मान लो ये हाइड्रोजन एटम का, हाइड्रोजन मॉलिक्यूल का, हाइड्रोजन एटम, ये हाइड्रोजन एटम है, ये और एक हाइड्रोजन एटम है, ये दोनों मिक्स करके आपका मिलेगा बॉन्डिंग मॉलिक्यूलर ऑर्बिटल, एंटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल, है ना? सो दिस इज एन ऑर्बिटल ऑफ 1s ऑर्बिटल एंड दिस इज 1s ऑर्बिटल. ये दोनों मिक्स करके ये सिग्मा ऑर्बिटल, ये सिग्मा स्टार ऑर्बिटल आएगा. ये सिग्मा इज कॉल्ड बॉन्डिंग मॉलिक्यूलर ऑर्बिटल एंड सिग्मा स्टार इज कॉल्ड एंटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल. एक खास बात है, ये मॉलिक्यूलर ऑर्बिटल थ्योरी आपका समझने के लिए बहुत खास बात है, लेकिन अब मेरे पास एक ट्रिक है, ये कैसे इस्तेमाल कर सकते हैं. ये ट्रिक इस्तेमाल करके आप सीधा क्वेश्चन विदाउट सॉल्विंग यू कैन गिव द आंसर. ख्याल में रखो, है ना? मैं वादा दे रहा हूं. ओके, ये ट्रिक अच्छा है, अगले स्लाइड में आपको मिलेगा. वेट, स्टे ट्यून्ड. यस, एंड हायर एनर्जी, लोअर स्टेबिलिटी. अच्छा बात है बेटा, आप जो बोल रहे हैं ना सही बात है. एंड कैन ए मॉलिक्यूल विथ ऑड नंबर ऑफ इलेक्ट्रॉन एवर बी डायमैग्नेटिक? एक्सप्लेन व्हाई एंड व्हाई नॉट. हाँ, yes it is. Yes, number of electrons, odd number of electrons, molecule with odd number of electrons is always paramagnetic. It need not be diamagnetic. If it is, you can say it is diamagnetic if that odd electron is delocalized. And most of the cases, if odd electron है, ये paramagnet होगा. Got it? Got it? Shivansh is fine. Now let's talk about formation of bonding and anti-bonding molecular orbital. Yes. So मेरा ये जो है atomic orbital mix ना, it is going to give bonding molecular orbital with low energy, anti-bonding orbital with high energy. So that's the spirit in the class. So the doubts you are giving to me, without hesitation, I am going to give you the answer like a pro, because you are sitting in a class with a senior most faculty from Infinity Learn, and get advantage of these sessions and you will be the topper. You will be awesome, right? Now in molecular orbital theory, the orbitals are identified as sigma orbital or pi orbital depending upon the type of the symmetry of the molecular orbital. What is sigma? Sigma is axial overlapping, pi is a lateral overlapping of the Abhi. Now, good afternoon. Good afternoon, my dear sweet student. Every day coming late. Why? School है क्या? School चालू है? Axial overlapping जो है sigma bond होगा and lateral overlapping है pi bond होगा, right? That you already know from the valence bond theory. Compare the atomic molecular orbital diagrams, identify the number of each of the following pairs has the highest first ionization energy. Yes, we can do that. We can do that in the gas phase. Okay. Shivans, we can do that. Hold on, I am going to compare that also. So H, H2N, N2O, O2C, C2B, B2. So it is a comparison when this is transformed. Everything I am going to give you. So if you want to get that diagram, you can do it. I am going to give the diagram as well. Okay. So a sigma molecular orbital. Let me finish this, Shivans. थोड़े से देर में मेरा ये थोड़ा concept आपका delivery करना है. ये molecular orbital theory का बाद आप hydrogen bond भी देखना है. आज ज़्यादा चीज़ ये discuss करने के लिए है ना? अरे no, okay, no problem बेटा, no problem. So आगे बढ़ेंगे थोड़ा. Now molecular orbitals, sigma molecular orbital is a cylindrical symmetry. Whenever a orbital and a orbital mix करने तो ये होगा आपका cylindrical symmetry. Cylindrical symmetry कैसे देखते हैं? ये ऐसे है ना? This is what you call it as nucleus. This is your nucleus. Okay, this is your nucleus and this is your nucleus, and this is internuclear axis. This is what you call it as internuclear axis. Yes, this is your internuclear axis. में एक cylinder देख सकते हैं. That is what you can say is a sigma bond. And when you talk about this increasing energy का and psi A, an atomic orbital of atom A, and psi B, atomic orbital of atom B, when they combine ना sigma bond form होगा, क्योंकि addition format में है. Bonding orbital lower energy than that of atomic orbital. That's what you want to say. रेहान आप जो बोल रहे थे ना इस ए चीज का है. What is the formation of bonding molecular orbital and anti-bonding molecular orbital? Yes, it is. This is bonding molecular orbital, Shivans. And when the orbitals are formed by subtraction of the wave, it is going to form anti-bonding molecular orbital. अब जो डाउट पूछ रहे थे ना इसका आंसर ये होगा. एंड कंबाइनिंग जो ऑर्बिटल है एटॉमिक ऑर्बिटल ऑफ ए, एटॉमिक ऑर्बिटल ऑफ बी, ये दोनों का एनर्जी कम से कम बराबर होना चाहिए. ये एनर्जी स्केल में देखो बराबर देख रहे हैं. सो साई व्हाट इज इट्स सिग्निफिकेंस? सो व्हेन द इलेक्ट्रॉन इज मूविंग इन दिस वे, सो इट इज इन द फॉर्म ऑफ वेव, है ना. ये वेव का जो एम्पलीट्यूड है ना, एंड दिस एम्पलीट्यूड ऑफ द इलेक्ट्रॉन वेव is indicated with psi. Got it? Yes, Rehan Jafri, fine. Psi has no physical significance क्योंकि psi का वैल्यू पॉजिटिव होता है, नेगेटिव होता है. इसी का कारण आप psi स्क्वायर इस्तेमाल करते हैं. psi square indicates the probability finding of an electron. Thank you very much. At least you got an anticipation in the class, है ना. So any doubt you are asking, my dear students, it is definitely honored if it is related to the context. If you are asking about something other than academics, no, I am not going to care of that particular comment. है ना. This is a live session, is not a radio session, which should be needed for F2 generate an ion with a bond order is to, yeah, हम देख सकते हैं student. Shivansh, we can see that. Let me finish that. Once bond order is completed, I'll get back to your question. है ना? Right. So let's talk about this is how. This is how. So if this is s orbital combined sigma 1s orbital, sigma 2s orbital. है ना? If you say 2p orbital combines, na, you are going to get a sigma 2p, sigma star 2p, like that. And you can see the bonding orbital is designated as simply as sigma and anti-bonding sigma orbital and anti-bonding sigma star. जहां पर star है anti-bonding orbital होगा, right? And such sigma bonds are formed when any two p orbitals overlap in end on end along their axis positions. So this is axis. Okay, this is axis. So along the axis they are going to form sigma star. This is the nucleus, this is the nucleus, this is the nucleus. Nucleus का बीच में ज़्यादा electron cloud आ रहा है ना, so it is bonding molecular orbital, and this is anti-bonding molecular orbital. So anti-bonding molecular orbital में कम electron cloud nucleus का बीच में आता है. Now if it is a pi bond, since the energy of the molecular orbital is directly related to the number of nodal planes, the pi orbital is more energetic than the sigma orbital. This explains why pi bond is weaker than a sigma bond. We all know in the valence bond theory, sigma bond is axial and more stable, pi bond is lateral and less stable. But यहाँ पर ये देता है आपका the reason where pi bond is weaker than sigma bond. My dear students, NEET examination में आप 2024 में देख चुका. So statement 1 and statement 2 का questions आता है. So you can say we can say pi bond is weaker than sigma bond. This is मान लो ये statement 1 होगा, and reason आता है the energy of these directly proportional to nodal plane. Pi bond is more energetic than sigma bond. This comes as statement 2, and statement 1 and statement 2 is correct, or assertion and reason is correct, and the reason is the correct explanation of assertion. You can say these are the type of questions. You can say अरे I know it, molecular orbital theory में का अच्छा तरफ आता है, ओके वेरी गुड, लेकिन ये छोटा का चीज के एक स्टेटमेंट 1 स्टेटमेंट 2 बनाने के बाद आपका जिस क्वेश्चन आता है ना, ये एनालाइज करके सही आंसर देना. सो सच है, सब आपके सामने है, आंसर देने का आपको जटिल होता है. सो यू विल बी इन ए डायलेमा व्हिच आंसर शुड बी गिवन. Suhars, hello, yes, good to see, hello. And this kind of questions आपको आदत होने के लिए तैयार रखो, and definitely you will be getting a very good score. Please make a note of this. Yes. Now 680 number in NEET examination, congratulations. Okay, आपका 700 क्रॉस करना अगले 2025 नीट में 720 तैयार है. तिवारी तैयार है 720 मिलने का. ऑल इंडिया इंस्टीट्यूट ऑफ मेडिकल साइंसेस न्यू दिल्ली को जाना. रेहान जाफरी, पाई बॉन्ड इज मोर नोडल प्लेन्स. ऑफ कोर्स आपका जो सिग्मा बॉन्ड है ना, ओके, सिग्मा बॉन्ड में देखो नोडल प्लेन सिर्फ यहां पर एक है, ओके, यहां पर एक नोडल प्लेन है, यहां पर एक नोडल प्लेन है. पाई बॉन्ड है ना, नोडल प्लेन कितना देख रहे हैं, देखो मोर नोडल प्लेन्स ना. यस, एम सही है, डेफिनेटली विल गेट इट. यस, 2 जनरल क्राइटेरिया व्हिच डिटरमाइन द एनर्जी ऑफ द मॉलिक्यूलर ऑर्बिटल. पहला जो है इनिशियल एनर्जी ऑफ द एटॉमिक ऑर्बिटल्स, दूसरा के एक्सटेंट ऑफ द ओवरलैपिंग ऑफ द ऑर्बिटल्स, है ना. ओके, अब भी ओके. तिवारी, यस, एम्स चाहिए, हाँ जरूर मिलेगा, जरूर मिलेगा. ओके, सो टू जनरल क्राइटेरिया ऑफ द स्टेबिलिटी ऑफ द ऑर्बिटल, पहले जो है बेटा इनिशियल एनर्जी ऑफ द एटॉमिक ऑर्बिटल है, दूसरा ही एक्सटेंट ऑफ ओवरलैपिंग ऑफ द एटॉमिक ऑर्बिटल्स है. सो इट इज ऑब्वियस दैट मॉलिक्यूलर ऑर्बिटल फॉर्म्ड विथ लोअर एटॉमिक एनर्जी आर more stable, higher energy or less stable. So that's very, very important. That's what whenever molecular orbital theory comes now, simply you just make a line like this, है ना. So it gives like this. Okay, atomic orbital, bonding molecular orbital, anti-bonding molecular orbital. फिर भी atomic orbital same energy, bonding molecular low energy, anti-bonding molecular higher energy. जितना atomic orbitals combine कर रहे हैं ना, उतना ही molecular orbitals produce करना चाहिए. Very good. Yeah, I'll solve your question बेटा, don't worry. थोड़ा सा रुकना हो बेटा, कॉन्सेप्ट चल रहे हैं, कॉन्सेप्ट करने के बाद आपका क्वेश्चन का सारे के सारा आंसर आपको मिलेगा. Why you are laughing? Okay, very good. So as a sigma overlap is more effective than pi, so sigma bond is having a more electron cloud between the nucleus and low energy and high stability than the pi molecular orbitals. So the orbitals energy is going to be sigma 1s orbital is less than sigma 1s orbital is less than sigma 2s, sigma star 2s, sigma 2pz, pi 2px and pi 2py. These two are degenerate. जिस ऑर्बिटल का एनर्जी सेम होगा वो डीजेनरेट है ना. रेहान, यू सेड व्हाट इज डीजेनरेट. जफरी, राइट. You said the unknowns are not you. Okay, no problem, no problem. That is not unknown. He is my beloved student Abhinav. Abhinav. कोई प्रॉब्लम नहीं, मैं खुद सॉल्व करूंगा. अभिनव, टेक केयर, एंड सुहर्ष, फाइन. एंड लेट अस सी, ये चीज ख्याल में रखो बेटा, सारे इंपॉर्टेंट चीज है. मेमोराइज, मेमोराइज. ओके, राइट. Yes, let's focus. Right, beta? And everybody take a snapshot of this. Everybody take a snapshot of this. Yes, 3, 2, 1. Right? Okay, now 2s orbital combine, sigma 2s lower energy, sigma star 2s higher energy, right? And फिर भी 2p orbital, in that px, py and pz, px, py and pz. So z orbitals first combine sigma 2pz and pi 2px and pi 2py. After that it is pi star 2px and 2py and sigma star 2pz. So this is how the orbitals are going to be. Yes, we'll do that. That is oxygen, dear Tiwari. That is oxygen. Which of the period 2 homonuclear diatomic molecules are predicted to be paramagnetic? That is O2. Fine, that is O2. I read your question. That is your answer. Oxygen in the second period. 1s to 2s to 2p4. Right, beta? That's good. So, and when the electrons are filled, they are filled in this increasing order like this. Right? And this is true only energy level diagram for oxygen and fluorine and neon and above. That's good. अरे क्वेश्चन देखने के बाद आप आंसर दे सकते हैं बेटा. एक्सपीरियंस, अरे गेट एडवांटेज ऑफ दिस एक्सपीरियंस, है ना. नो हॉट फीलिंग्स, वी आर ऑल फ्रेंड्स हियर, वी कैन डू द बेस्ट. हाँ, यस. नाउ अरे पहले ये ऑक्सीजन एंड ऑक्सीजन के बाद ये सीक्वेंस इस्तेमाल करो. यस, इट इज मोर देन 14 का है, ये मोर देन 14 का है बेटा, है ना. Right. Now, so it may be noted that pi 2py type 2px bonding molecular orbitals are degenerate. That's what I mentioned. Degenerate orbitals means, Rehan, orbitals with similar energy. Yes. And similarly, pi star 2px, pi star 2py, these two are degenerate and these two are degenerate. है ना? And it has been found experimentally that some of the diatomic molecule like 2pz molecular orbital is high energy than 2py and 2px molecular orbital. Therefore, the order increasing energy for changes up to nitrogen appears like this. So, this is very, very important. Very, very important. So, up to nitrogen, this is up to nitrogen, you have to use 1s, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px is equal to pi 2py, then sigma 2pz is coming. Only the difference makes here, not any other place. Yes, degenerate means electron can change its position without energy requirement, right? Without energy requirement from the outer side. Okay, what you said is correct, Rehan, but there is an exchange energy. Okay, because of that exchange energy, the electron is going to occupy all these available orbital at that sub energy level. Rehan, I am extending your point. Ashfaq, okay, you are a new student. Okay, Now let's talk about the main difference between the two types of sequence and energy level is that molecule of O2, F2, N2 hypothetical, and the 2pz molecular orbital is lower energy than 2px and 2py. That's what I mentioned here, right beta? And in case of molecule like lithium, beryllium, boron, carbon, nitrogen, it is up to 14 electrons, and this is more than 14 electrons. ये चीज है more than 8 electrons को ये चीज इस्तेमाल करो. Bonding, why are anti-bonding orbital have higher energy? Tiwari, anti-bonding orbitals have high energy because they are formed by destructive interface of the atomic orbitals, so that they have very less electron cloud between the two nuclei, so that the bond is less stable due to high energy. Got it? They are formed by destructive interface of atomic orbitals, my dear. Right, beta? Now, so this is what? Molecular energy diagram for lithium, beryllium, boron, carbon, nitrogen. So, up to nitrogen. Sigma 2s, sigma star 2s, pi 2px, pi 2py, sigma 2pz, and pi star 2px and pi star 2py and sigma star 2pz. Yes. Yes, destructive interface has high energy. We don't say high repulsion. Got it. Now, so using a preceding figure, respective molecules guide, okay. So, when these orbitals are formed, these orbitals are filled with the electrons. These molecular orbitals are filled with electrons, and this filling of the electrons should be governed by Aufbau principle, Pauli's exclusion principle, and Hund's rule of maximum multiplicity. So, Aufbau principle says molecular orbital with low energy is first filled, then higher energy orbitals are next filled. Then Hund's rule says pairing cannot take place unless these orbitals are filled with at least one electron with parallel spin, okay, then half filling, then it is start pairing, you know. And Pauli's exclusion principle, no two electron can have the same set of quantum numbers, or you can say an orbital can have maximum of 2 electrons. Yes, Tiwari is fine, got it, very good, nice. So, what is the bond order? So, in atomic orbitals combine to form the molecular orbitals. According to molecular orbital theory, the bond order is given as half into NB minus NA. The unknown, I am not your teacher, Tiwari. What is this? Okay. No, you not know the answer of the question. What do you want to say? I don't understand. Okay. So, the bond order can be calculated based on this. This bond order is directly gives the stability. Okay. NB is the number of electrons and number of electron pairs. No, number of electrons, Rehan. So, NB stands here. NB stands here, number of electrons in bonding molecular orbitals. Na talks about number of electrons in anti-bonding molecular orbitals, ABMO, right? Yes, it is correct. And if the bond order is 1, 2, 3, 1 means single bond, 2 means double bond, 3 means triple bond. It could be fractional also. If bond order is 0, it is going to be not existed. Anyways, since the electron bonded NB I have given here, what is the denomination over there? If NB is greater than Na, the molecule is stable. If NB is less than Na, the molecule is unstable. If even NB is equal to Na, the molecule is unstable. Okay. So, the stability is governed by the various factors in that case. That is very, very important point. So, this is due to the fact that anti-bonding effect is sum of the stronger than the bonding effect. Okay, right. So bond order is equal to 1 by 2 n by nb minus na. कर सकते. Now stability of the molecule is directly proportional to the bond order, and the dissociation energy or bond energy is directly proportional to the bond order, my dear students. Bond length inversely proportional to the bond order. These are the important points, important checkpoint application of molecular orbital theory. है ना? Now, if all the electrons in a molecule are paired, then the substance is diamagnetic. If there is an unpaired electron, the substance is to be paramagnetic, and the magnetic moment can be calculated by using mu is equal to root over n into n plus 2. उसमें n होता है क्या रेहान जाफरी? आप बोल सकते हैं? अभिनव, n होता है क्या इसमें? Yes. तिवारी, yes. What is dissociation energy? Rehan, the amount of energy that required to break 1 mole of bond is called as bond dissociation energy और bond energy. ओके, जिस बॉन्ड ज़्यादा स्टेबल है इसका बॉन्ड डिसोसिएशन एनर्जी ज़्यादा होगा, क्योंकि ये बॉन्ड्स ब्रेक करने का बहुत मेहनत करना पड़ता है बेटा. यस, यू अंडरस्टैंड रेहन? गॉट इट? वेरी गुड, दैट्स गुड. So where n is equal number of unpaired electron, किसमें? मॉलिक्यूलर ऑर्बिटल कॉन्फ़िगरेशन में. मॉलिक्यूलर ऑर्बिटल कॉन्फ़िगरेशन में समझ में रहेगा? दैट्स वेरी गुड. अगर मैग्नेटिक मूवमेंट जीरो होगा, ये यूनिट्स बोर मैग्नेटन इज द यूनिट बेटा, सो जीरो होगा, देन इट इज सेड टू बी डायमैग्नेटिक है. सो इफ द मैग्नेटिक मूवमेंट ग्रेटर देन जीरो होगा, देन इट इज डायमैग्नेटिक है. Yes, very good. Now, so take a snapshot of this. This also, this also, this also. First you take a snapshot of this. Everybody, come on. Take in 3, 2, 1. And फिर भी ये वाला एक snapshot ले लो. Yes. Take in 3, 2, 1. Because these points we are using and taking care when we apply. So homoatomic molecules H2 हाइड्रोजन मिलने के बाद H2 is 1s2. कैसे? हाइड्रोजन में आपका 1s1 कॉन्फ़िगरेशन है. So हाइड्रोजन प्लस हाइड्रोजन gives rise H2 molecule. 1 electron, it has 2 electron. ये 2 electron सिग्मा 1s2 होगा, है ना. बॉन्ड ऑर्डर इज इक्वल टू एन बी माइनस एन ए बाई 2. ये बॉन्डिंग ऑर्बिटल में है, ये बॉन्डिंग ऑर्बिटल में है ना, ये बॉन्डिंग ऑर्बिटल में. सो दैट 2 माइनस 0 बाई 2 इज इक्वल टू 1. सो इट इज बॉन्ड ऑर्डर इज 1, सो दैट सिंगल बॉन्ड एग्जिस्ट. यस, mu is greater than 0, it is paramagnetic. So I am from Hyderabad. Here it is from Infinity Land corporate office, and in the YouTube channel studio में है अभी, है ना. And the bond order, if you talk about the helium, so helium and helium combine करके He2 मिलेगा. हर helium atom में 2 इलेक्ट्रॉन है, 2 इलेक्ट्रॉन मिलके 4 इलेक्ट्रॉन फॉर्म होगा ना. ये 4 इलेक्ट्रॉन. So helium 2 sigma 1s2 sigma star 1s2. So that bond order of helium 2 is 1 by 2, 2 minus 2 is equal to 0. अगर 0 होगा तो there is no bond exist. Therefore you can say helium 2 doesn't exist. Helium 2 doesn't exist. समझ में आ रही क्या? Sir, you are from Delhi. वेरी गुड. सुप्रीम कोर्ट में क्या चल रहा है? ओके. सो कल था हमारा टीम सुप्रीम कोर्ट के सामने. ओके, यू आर फ्रॉम आसाम. किस प्लेस में है आसाम? अभिनव. molecular orbital theory is not applied on me, it is applied on the molecules. ओके राइट, कल अब भी थे सुप्रीम कोर्ट के सामने। ओके अभिनव, असम में कहां से तू? हाँ हाँ, आपका भाया वकील है, कोई प्रॉब्लम नहीं। देखो नाउ लिथियम मॉलिक्यूल, लिथियम हाइड्रोजन हीलियम लिथियम, लिथियम में 3 गोलाघाट, वेरी गुड। मैं गए थे 10 साल पहले गोलाघाट, ओके, काजीरंगा, कोकराझार, तिनसुकिया, गुवाहाटी, सब प्लेसेस में घूम के आए थे। ओके यू आर फ्रॉम कश्मीर, फिलहाल अभी मैं आया नहीं पर ओके सो उस समय में आप छोटा बच्चा होता है शायद। ओके लिथियम, उसमें 3 इलेक्ट्रॉन है और एक लिथियम से मुलाकात करने 3 इलेक्ट्रॉन है, लिथियम 2 होने 6 इलेक्ट्रॉन के साथ। सो लिथियम 2 has 6 electrons, sigma 1s2, sigma star 1s2, sigma 2s2. So if you want to calculate the bond order, therefore half into 4 minus 2, 1, and it is diamagnetic carbon molecule. So carbon plus carbon, 6 plus 6 is equal 12 electrons, my dear students. So its electron configuration 1s2, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px2, pi 2py2. So that yes, Li2 can exist. Yes, your smallest unit of the atom is atom. Okay, so atom you can't further break it, that's a different matter. हाँ पक्का आऊँगा, डेफिनेटली। यू कम टू इन्फिनिटी लेन कॉर्पोरेट ऑफिस हैदराबाद, एक बार मिलने के लिए आप आना है। ओके सो दैट दिस इज डायमैग्नेटिक, दिस इज डायमैग्नेटिक एंड दिस इज आल्सो डायमैग्नेटिक। इसका एक बार देखना, यू कैन से स्ट्रक्चर ऐसे भी देख सकते हैं क्योंकि के स्टार क्या, सो के शेल का है, सेकेंड शेल मीन्स एल शेल का है ना। yes, now it is going to be bond order is 2, so bond order is 2, so 1 by 2 into 8 minus 4 is equal to 2, it is diamagnetic. Like that nitrogen molecule, this is the structure, nitrogen atom मिलके, so nitrogen molecule बन गया 7 electrons 14 electrons बन गया। these 14 electrons are written like this, so फिर भी ये diamagnetic है and bond order is 3, है ना। yes, correct। oxygen molecule, so oxygen plus oxygen gives rise oxygen molecule, 8 electron and it is 16 electrons, so 16 electrons are written like this, so sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. now this order is changed and this has to be written here, as this place is not here, I just want to write here. So we are talking about first ionization energy and the molecular orbital electron is removed from in the first ionization energy, the electron is removed from here in the first ionization process. Got it? Fine. O2 is not exception, O2 is not exception, O2 से ये ऑर्डर फॉलो करना, O2 का पहले ये ऑर्डर फॉलो करना रेहान। फाइन बेटा, it is not an exception. So there are 2 types of orders, one is up to nitrogen, another one is from oxygen onwards, है ना, right। So the bond order is going to be 3 for nitrogen, oxygen it is going to be 2, है ना। now I just want to say there is an unpaired electron, there is an unpaired electron, unpaired electron. So n is equal to 1, mu is equal to root over n into n plus 2, that is equal to root over 1 into 1 plus 2 is equal to root 3 is equal to mu is equal to 1.732 Bohr magneton. So it is paramagnetic. It is paramagnetic, my dear students. Clear beta? Very good. I will solve it now. Let me finish this trick also. So now let us talk about carbon monoxide. So carbon का पहले देखो, कार्बन का 6 इलेक्ट्रॉन्स है, ऑक्सीजन का 8 इलेक्ट्रॉन्स है, यू आर गोइंग टू गेट 14 इलेक्ट्रॉन्स है. 14 इलेक्ट्रॉन्स का कॉन्फ़िगरेशन ऐसे लिखा, एंड इट इज गोइंग टू गिव द बॉन्ड ऑर्डर इज 3. So yes, definitely I'll do it yaar. I'll do it, don't worry. Okay, fikar mat karo. Okay, and it is going to be diamagnetic because this is odd electron species nahi hai, even electron ka hai. Wherever even electrons, bond order bhi ye whole number hai. So you can say total number of electrons and bond order also to say the magnetic moment. Okay, you can say nitric oxide. Nitric oxide total valence electrons are 15. Let me talk about this only. Let me finish this. Okay, now it is going to give you bond order 2.5, and you have a beautiful trick. My dear students, you are all waiting for this trick. So in the molecular orbital theory, are you get ready for the trick, right? Thank you very much. Okay, we'll do that, don't worry. Rehan Jafri, come on, let us do it. Here, a trick. Now, don't look at anything. Number of electrons, you count from 9 to 20. Number of electrons 9 to 20. And 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now you take the bond order 0.5. You increase the 0.5, and up to here. Maximum bond order is only 3. From here, you decrease the bond order 0.5, decrease 0. That's it. Now, whenever something is coming, look at this. Nitric oxide, number of electrons are 15. है ना? 15, है ना? Right, you don't memorize this. Take this 15. This 15 bond order seems to be 2.5. Right? Now we look at this. This 15 bond order is 2.5. Who asked you to calculate? Simple na? Tiwari fine. Rehan Jafri, anything you can calculate from this. Anything. Yes, you will get the same answer. Tiwari, you will get the answer here itself, right? Yes. Now, जहां पर आपका ओल नंबर है, ये पैरामैग्नेटिक है ना, पैरामैग्नेटिक पहले जो 3 है, and it is going to be diamagnetic. डेसिमल वाला पैरामैग्नेटिक, it is dia. Okay, डेसिमल वाला पैरामैग्नेटिक है, ओल नंबर वाला diamagnetic है, and decimal वाला paramagnetic है. Okay, so it is going to be anything. 2.5 decimal number paramagnetic, 2.0 okay, it is diamagnetic. Okay, 1.5 decimal वाला paramagnetic, 1.0 diamagnetic, 0.5 paramagnetic, 0 it do not exist. Clear? Yes, come on, everybody, take care of this. Many things you can do it. So find the magnetic moment of Cn minus NO2 minus O2 minus. Now a ion का है पहले. Yes, you got, say, very good, 680 marks. Nice. Now Cn minus number of electrons, carbon का 6 and nitrogen का 7 and -1 का वजह से और एक electron add करना है. So total 14 electrons. Are you getting or not? 14 electrons, number of unpaired electrons 0 and paramagnetic, and it is diamagnetic. And you can calculate magnetic moment NO minus 16 electrons, and it is going to be 2. And O2 minus 17 electrons, it is going to be minus 3. root 3. Like that you can calculate. Now you can see Li2, Be2, B2, C2, N2 plus, N2, CO, NO, O2, O2 minus, F2, F2 minus, Na2. Simply you can calculate the total number of electrons, number of unpaired electrons. You can calculate bond order and number of unpaired electrons, whether it is a paramagnetic and diamagnetic, you can say that, right? Yes, very good. Now this is the example where you can focus it on how you write the electronic configuration, what is the order we follow here, what is the order we follow here, तब आपको पता चलेगा. So Insta ID is there on the description box, Tiwari. Okay? Yes. Now you can see questions we are doing in the class. Now the paramagnetic nature of oxygen is the best explained by, who is going to give the answer? फटाफट देना, चलो शिवांश, give the answer. फटाफट देना, जल्दी बताओ आपका आंसर चार्ट बॉक्स में. इट इज सी. It is C. Yes, it is explained by molecular orbital theory. Got it? So magnetic, actually when we start with molecular orbital theory, we talk about this molecular orbital theory with the magnetic nature of oxygen only. है ना? Fine. Clear? That's good. Now और एक क्वेश्चन आपके सामने तैयार है. Number of anti-bonding electrons in oxygen molecules are, you need to know what is the actual electronic configuration of this. It is 3 want to say. Okay, right. So electronic configuration of the oxygen, it is equal to 16 sigma 1s2 sigma star 1s2 sigma 2s2 sigma star 2s2 sigma 2pz, okay, pi 2px 2 pi 2py2 and sigma pi star 2px1 pi star 2py1. So 1 2 3 4 5 6, that is your answer. 6 is the answer. Got it? Yes, due to presence of this unpaired electron, O2 is found to be paramagnetic in nature. What you said is correct. Yes, it is. So what are the antibonded electrons here? Here स्टार वाला का है, सिर्फ स्टार वाला का है ना. Yeah, I'm in way. That's good. Total 6 electrons are there. Very good. Wait for some time. Now और एक क्वेश्चन है. Now bond energy is maximum in, अरे आप कौन दे सकते हैं? शिवांश, तिवारी, Abhinav, Rehan, come on. Rehan. So this is a quite interactive session, my dear students. So I am really enjoying with you. You want to say D? Okay. So bond energy में आपका एक चीज देना चाहता हूँ. Bond energy is directly proportional to bond order. ये चीज का बता. N2 molecule. Yes. So जिसका bond order 1, bond order 3, bond order 2, bond order 1. Sir, I can calculate by using bond orders and molecular orbital theory. Or F2, everybody knows single bond. N2, everybody knows triple bond. O2, everybody knows it is double bond. And Br2, everybody knows is single bond. है ना? it is N2. See, no, 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 no. अरे you learn from mistakes, कोई प्रॉब्लम नहीं है ना रेहान. सो हर दिन आना कोशिश करो बेटा, अब मैं ठीक करूंगा आपको, ठीक है. राइट. सो मेरा आंसर है, शिवांश बोल रहे थे बिल्कुल सही जवाब है, दैट इज नाइट्रोजन, ऑप्शन 2 है. सर वॉइस नहीं आ रहे, सो माय वॉइस इज ऑडिबल. अभिनव कंफर्म करो, मेरा वॉइस, मेरा आवाज सुनाई दे रही है क्या? Okay, right, all clear, that's fine. So which of the following molecular orbital has the lowest energy of O2 molecule? Yes, उसमें कौन सा ऑर्बिटल का एनर्जी कम से कम है? Yes, it is जफरी, किस ऑर्बिटल का एनर्जी कम है? For orbital of the oxygen, it is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px, sigma 2pz to pi 2px, pi 2py to pi star 2px 1, pi star 2py 1. दिस इज फॉर ऑक्सीजन. उसमें कम से कम एनर्जी 2pz का है. गॉट इट? सो आपका आंसर 1 होगा, आपका आंसर 1 होगा. क्लियर? यस इट इज. So it's an awesome experience that you are getting from. If you see in the NEET examination भी ऐसे क्वेश्चन, इससे जटिल क्वेश्चन आएगा. It's very simple. It's very simple. Got it? That's good. That's good. Yes, you are right. Shivans, Jeffrey also. Yes, it. No. Jeffrey, you correct yourself. Saurabh, अभी तक क्या कर रहे हो बेटा? Came late, so you are not chatting with me. Now अगले मॉलिक्यूल क्या? In oxygen molecule the correct order of energy is, 1 minute. Yes. In oxygen molecule the correct order of energy of the molecular orbitals are given as. So आपका आंसर क्या? Yes. Here it is. Abhinav, where are you? Where are you, beta? Now it is given as again ऑक्सीजन का, फिर भी इलेक्ट्रॉनिक कॉन्फ़िगरेशन लिखना, सिग्मा 1s2, सिग्मा स्टार 1s2, सिग्मा 2s2, सिग्मा स्टार 2s2, है ना. देन सिग्मा 2pz2, पाई 2px2, पाई 2py2, पाई स्टार 2px1, पाई स्टार 2py1. ये ऑक्सीजन का चीज है ना. या क्वेश्चंस नोट करना हुआ जो गलत हो रहे हैं, ऐसे नहीं. ओके. नाउ 2py 2pz, 2py 2pz का एनर्जी बराबर है. सो 2py 2pz गलत बात है. 2s सिग्मा 2s इज करेक्ट, इट इज करेक्ट. सिग्मा 2s सिग्मा 2px ये गलत बात है. सो सिग्मा 2s सिग्मा स्टार 2s2. Understand? So you are expecting somewhere some question, but you are getting the correct answer somewhere. Okay, Abhinav beta, right. So I just want to give the answer 3. है ना? It is answer 3. It's a very good interesting things you are doing. So I am correctly traveling, so I have no book, that's why. No problem, no problem. So you all get this notes in this telegram channel. So description box में telegram channel भी दिया. So ये telegram channel में आप join करो रेहान, so that you are going to get the notes. So okay, मैं yes, वासिफ hello, yes, हेलो बेटा, क्वेश्चन सॉल्व करते हैं, क्वेश्चन है ना, सॉल्व कर रहे हैं ना, यस, कोई प्रॉब्लम नहीं. व्हेन नाइट्रोजन गोस इनटू नाइट्रोजन प्लस देन n बॉन्ड डिस्टेंस एंड O गोस टू O2 प्लस O बॉन्ड डिस्टेंस इंक्रीज कर रहे हैं, डिक्रीज कर रहे हैं, है ना? यस, आपका क्वेश्चन ऐसे है ना? ओके, देख लीजिए हम कैसे कर सकते हैं. When nitrogen to nitrogen plus bond order is going to be decreased. Okay, so when nitrogen is converted into N2 plus, है ना? Oxygen is converted into O2 plus. देखो ये क्या हो रहा है. So उसमें 14 इलेक्ट्रॉन्स था, उसमें 13 इलेक्ट्रॉन्स हो गया, उसमें 16 इलेक्ट्रॉन्स था एंड इट इज गोइंग टू बी 15 इलेक्ट्रॉन्स हो गया. सो दैट व्हाट हैपेंस, इसका बॉन्ड ऑर्डर है, इसका बॉन्ड ऑर्डर है 3.0 था, इसका बॉन्ड ऑर्डर है 2.0 था, है ना? राइट. नाउ हमारा जो ट्रिक है ना, हमारा जो ट्रिक है ना, देखो, हाँ, यस, नाउ 14 इलेक्ट्रॉन बिकम 13 इलेक्ट्रॉन, बॉन्ड ऑर्डर 2.5 बन गया. 16 इलेक्ट्रॉन बिकम 15 इलेक्ट्रॉन, ओके, सो बॉन्ड ऑर्डर 2.5 बन गया, है ना? सो दैट यू कैन सी आवर क्वेश्चन. बॉन्ड ऑर्डर 2.5 बन गया, बॉन्ड ऑर्डर 2.5 बन गया. नाउ क्या सोच रहे हैं, बॉन्ड ऑर्डर बढ़ गया, यहां पर बॉन्ड ऑर्डर कम हो रहा है. सो यू आर आस्किंग अबाउट बॉन्ड ऑर्डर डिक्रीज्ड, सो बॉन्ड लेंथ इंक्रीज्ड and bond order increased and bond length decreased, increase and decrease, and this is my logic. नीट में ऐसा क्वेश्चंस आने का संभावना है बेटा, नीट में सीधा ऐसे क्वेश्चंस आते हैं. इफ यू वांट टू राइट एम्स काइंड ऑफ, if you want to go into the aims, you have to solve this logical analytical questions, my dear students, है ना? Very good. Hope you are all enjoying. Hope you are all enjoying these questions. So the electrons are removed from a bonding molecular orbital in nitrogen and the antibonding orbital from an oxygen. As per molecular orbital theory, it is a very good interpretation that is given here. Bond order inversely proportional to bond length. Rather, I just want to say bond length inversely proportional to bond order. So bond energy directly proportional to bond order. है ना? Clear? Yes. Lovely, lovely answer. Lovely answer. Now we are getting any doubt here? Yes. Wow. Nice emojis. Now time बहुत कम है. Let us talk about just introduction about hydrogen bonding. है ना? So hydrogen bonding is a kind of bonding where you can see hydrogen and fluoride and hydrogen and fluoride, and there is an electronegative difference between two atoms, so that a mild weak electrostatic forces of attraction that exist between most electropositive element, electronegative element and the hydrogen atom, and that bond is what you call it as a hydrogen bond. अगले सेशन में हम ये हाइड्रोजन बॉन्ड का बारे में देखने का कोशिश करता हूं. अभी टाइम बहुत कम हो गया, so that we can't extend this. Today we discussed about very good number of good questions previously, you can see, and this is the ultimate question that we had in the hybrid molecular orbital theory. Today we discussed about molecular orbital theory and conditions for molecular orbitals and the properties of the molecular orbitals and the applications of molecular orbital theory. So hope you enjoyed today's session. Abhinav, Rehan, that's good. Ionic bond is formed when a positive and negative charge bond together, of course. And Rehan Jaffrey, be regular in everyday session. Tomorrow we are going to discuss more stuff about the hydrogen bonding and bond parameters. Don't miss it, and please like, share, subscribe this channel and enjoy these sessions. Thank you. Signing off, Suresh, Faculty of Chemistry from Infinity Lane. Bye bye.